In this problem, we're going to be graphing 1/3 to the x power plus 2. This is an exponential because the exponent is a variable. In this case, it's x. Our base is 1/3, so we're going to expect this to be decay. And there's a vertical shift of up 2. Let's build a table of values, and then we'll relate the equation and the table of values to how the graph looks. The first one is f at -2, so we have to take 1/3 and raise that to the -2 power. Raising to a negative power could be flipping the fraction on the inside and then raising to the positive exponent. So 1/3 flipped, or the reciprocal of 1/3 is 3, and then we're going to raise that to the +2 power, then plus 2. So 3 squared is 9, plus 2 happens to be 11. So we're going to go left 2, that's your x value, up 11. So here's 10, and 11 would be just a little bit off the graph right here. Let's try 1/3 to the -1 power, then plus 2. So all we're doing here is just taking the x out and replacing it with -1 in this case. 1/3 to the -1 is the same as 3 to the first power. Once again, we can flip this fraction, raise to the positive exponent, plus 2. So 3 plus 2 is 5. So we'll go left 1, up 5. 1/3 to the 0 power will be easy to figure out. Anything to the 0 power is 1, then plus 2 is 3. So I'll go 0 and then up 3. There's your y-intercept, by the way. And then over here we have 1/3 to the first power plus 2. And 1/3 to the first power is just a third. Then plus 2 would get us to 2 1/3. So I'm going to go right 1, that's my x value, up 2 1/3. It'll be about right here. Next part I'll have 1/3 to the second power, then plus 2. 1/3 to the second is the same as 1/3 times a third, which is 1/9. Plus 2 gets us to 2 1/9. I like to use mixed numbers here to graph. It makes it a little bit easier. 2 1/9 means go up 2 1/9 more, so it's about right there. The next one is 1/3 to the third power plus 2. Oh, that's, let's see, 1/3 times a third times a third, which is 1/27, then plus 2 gets us to 2 and 1/27. So we'll go right 3 and up just a little bit. I know the shape of this graph, so I'm going to go ahead and draw it right now. And what I don't want to do is I don't want to cross over y is equal to 2. So I'm just going to try to get really, really close to it right there. This part of the expression, 1/3 to the x, can be close to 0, but we're always going to be adding 2. So you can't have any y values that are less than or lower than 2. We need to answer a few questions about this particular graph. So we'll take a look at the same graph. I went ahead and graphed that for you. And let's talk about the growth or decay rate. First of all, as we go from left to right, the y values are decreasing, so this is a situation that we would label as decay. The rate of decay is 1/3. The horizontal asymptote is that imaginary line that the function approaches or gets close to, kind of a helper line. So that's y is equal to 2. Our domain for all of these exponentials is -infinity to infinity. We can substitute any x value, even negative or positive. Fractions are okay. Irrational numbers like √2 are even okay. So the domain will be any real number. We represent that in interval notation just like this. The range is going to be close to 2, and then every y value from 2 to infinity, not including 2, of course. All of these y values are possible, but the graph does not exist below 2, so we don't want to list any value in our range that's below 2. Because this graph doesn't cross over the x-intercept, or the x-axis, excuse me, we can write none. For the y-intercept, we said that was 0, 3. And lastly, we're going to do some work with the end behavior here. And if we take a look at that end behavior as x approaches infinity, our y values get closer and closer and closer to 2. As x approaches negative infinity, those y values climb higher and higher, we would say without bound, and we're going to describe that left end behavior as x approaches negative infinity, f of x will approach infinity.